Earth, a planet wrapped in a dynamic web of life. The moon, its barren but inspiring companion, and the brilliant intruders that streak across our skies. Join us as we explore our own corner of the universe, next on Amazing Space. The spacecraft Galileo hurtles by Earth, its final destination, Jupiter. On its way, it captures the first images of planet Earth in rotation. The sun's reflection skims across the Pacific towards Australia. A compilation of cloudless satellite pictures shows the blue planet as never before, the ideal incubator for life. Now we see the upper atmosphere, the gaseous shield of the ozone layer, here in motion. It's this filter that protects us from solar radiation, that allowed life to take root on Earth. Over eons, plants have changed our atmosphere by breathing oxygen into it. Today, CFC emissions may be changing things again, starting with this hole in the ozone at the South Pole. Earth has a busy, sometimes violent atmosphere, made up mostly of nitrogen and about 20% oxygen. Though we may tamper with it, Earth's atmosphere in turn can unleash a fury that reminds us of who's really in charge. Some forces of nature are still beyond us. Wind systems are driven by hot air rising at the equator, twisted by the Earth's spin. That same spin gives us our daily mirage, the sun moving westward across the sky. In fact, the sun is relatively still. It's our planet that's moving, a 24-hour rotation that creates day and night. Time-lapse photography shows the moon, top left, sinking in the west. And here, the Milky Way and the stars seem to travel through the heavens. Again, it's not the stars that are moving. It's the Earth, rotating on its axis, that creates this turning panorama. Were Earth straightened up, day and night would be equal the world over. But the 23-degree tilt from vertical varies the length of night and day. As the tilted Earth orbits the sun, we get our seasons, defined by which part of the Earth is getting the better half of the sun and when. Here, summertime in the northern hemisphere. Satellite pictures reveal the changing seasons in Europe. They document the spread of vegetation growth as the northern hemisphere tilts toward the sun, bringing spring and then summer. In Antarctica, we can see the seasonal ebb and flow of the ice cap. "71% of the Earth's surface is ocean. The solid remainder began as one giant landmass some 250 million years ago. Ever since, its pieces have drifted towards their more familiar positions on plates that ride the Earth's molten mantle. These dots represent volcanoes, geologic hotspots that mark cracks in the Earth's surface where the continental plates meet. Even today, the drifting continues. This lava lake is like plates parting. And this like plates meeting and subducting. Where plates interact, volcanoes erupt. The Mount St. Helens volcano sits on the dividing line between the Pacific and North American plates. A sobering reminder of Earth's volatile interior. From high above the clouds, the signature of another eruption. Mount Pinatubo in the Philippines. Stratospheric pollution that reduced Earth's temperature by a degree as volcanic ash girdled the globe. Before Pinatubo, a sunset with stars. Afterwards, a red haze of volcanic dust. Here, a very different kind of pollution. The bright lights of civilization that obscure our view of the stars. In the future, the view from Earth will depend more on human factors than geological ones.
Amazing Space will return on TLC. Amazing Space now continues on TLC.
These are the first pictures of Earth and Moon moving together in space. Here, close-ups of the Moon's lava fields, colored in ways that highlight a contrasting landscape. The spacecraft Galileo captured these astounding images while testing its equipment before slingshotting towards Jupiter. Galileo sailed over the lunar North Pole, a region difficult to see from Earth. Like much of the Moon's surface, the pole is scarred by craters, most blasted out by meteors in the hectic heydays of a newly formed solar system, some 4.5 billion years ago. Despite the lack of air, the Moon is ripe for colonization. In the 21st century, we may set about building lunar bases, self-sufficient stations that wring oxygen from lunar rock. Pioneers will explore the Moon for raw materials, conduct radio astronomy, free from static on Earth, and take cosmic pictures undistorted by atmosphere. The Moon from Earth's point of view. These are the scans through a telescope, like the view from an orbiting satellite. Here, a huge crater, and mountain ranges like those on the planet Mercury. The bright highlands peppered with craters. Moon watchers once thought these were oceans, dark seas covering 15% of the surface. We now know they're impact scars filled and smoothed over by ancient lava. From 240,000 miles away on Earth, the crater Copernicus. A vantage point over the poles reveals the source of the Moon's familiar phases. As it orbits Earth, catching different angles of sunlight, it waxes and wanes to an earthbound observer. Again, with a central frame showing the Moon phases we see on Earth. The Moon rotates as quickly as it revolves, and always shows the same face to Earth. Only if the Moon stopped in its orbit would its rotation be apparent. Compared to Earth, the Moon is rather small. It would fit across North America. Earth is about 4 times wider across than the Moon. Some 240,000 miles separate us. 30 Earths would bridge the gap. The Moon is close enough to influence things on Earth. Some would say it gives rise to lunacy, but we know for a fact that it gives rise to tides. The Moon's gravity tugs at our oceans. Add that to the Moon's orbit and Earth's rotation, and the seas move with an ebb and flow that can leave a lighthouse stranded on an island. About once a year, the Moon falls under the shadow of Earth, producing a lunar eclipse. The Earth's dusty atmosphere bends sunlight back on the Moon, bathing it in a red glow. Although a total solar eclipse lasts just minutes, a lunar eclipse can last hours. The Moon is 400 times nearer to Earth than the Sun, which creates an astonishing effect during a solar eclipse as its shadow scoots across the Earth. By neat geometrical coincidence, the Moon is also 400 times smaller than the Sun. This means that it can fit perfectly over the Sun's disk, producing a total solar eclipse. This familiar sight has inspired the imaginations of men and women throughout the ages, fueling myth and metaphor. But can science tell us where it came from? Could it have come from Earth? When Earth was very young, it may have been struck by a smaller would-be planet. The collision blew both apart. As Earth reformed, lighter material fell into orbit around it and shaped a moon. Slowly, it cooled. Its crust solidified. But over eons, cosmic debris bombarded the Moon. Great basins were left, filling with molten rock from the interior. These hardened to shape the familiar moonscape that has so long beckoned to humankind.
Amazing Space will return on TLC. Amazing Space now continues on TLC.
Within the clockwork precision of our planetary system, there are rogues, things with strange and varied orbits that defy our orderly image of the cosmos. Some plunge directly into the sun. Others just miss. Comets and their cousins, asteroids, are the wild cards of the planetary pack. This is amateur video of cosmic debris falling to Earth as a fireball. Such flotsam from space may have doomed the dinosaurs. A 6-mile-wide asteroid may have struck Earth, raising a cloud of dust that shut out the sun and ushering in a prolonged winter. Along with most other living creatures, the dinosaurs perished. Comets come from the Oort cloud, a halo of debris beyond the farthest planets, drawn in by the sun's gravity. A comet is a dirty snowball, icy space junk left over from the formation of the solar system. But as it nears the sun, it undergoes an incredible metamorphosis. It begins to effervesce. The sun's heat vaporizes part of the comet. Gas and dust stream off as a tail of plasma. By now, the comet is in close solar orbit, its glowing tail blown backwards by the solar wind. The comet sports this classic shape only when it's close to the sun. Farther out, the tail disappears. A photograph shows its features. The nucleus is shrouded in a dense cloud called the coma. There are yellow tails of dust and a straighter tail of ionized gas, fluorescing blue over millions of miles. The most celebrated comet is this one, Halley. Comet Halley carves a huge ellipse through the solar system every 76 years. From its farthest point beyond Neptune, Halley hurtles toward the inner planets. The comet last rounded the Sun in 1986. It was Halley's first appearance in the age of spaceflight. The European probe Giotto went to get a closer look and took a plunge into Halley's coma. These are Giotto's pictures. At the center, the nucleus measured about 5 by 9 miles. Each second, it spewed 20 tons of gas and 10 tons of dust. Battered by debris from the coma, Giotto flew within 350 miles of the nucleus. From Earth, this is our best picture. But as Halley receded, its image faded. Then in 1990, it brightened. Scientists think the comet may have been struck by an asteroid, or there'd been some sort of explosion. Each time it swings past the sun, a comet leaves a trail of debris. Sometimes Earth blunders through that trail, and the result is shooting stars. These are showers of cometary dust burning up in the atmosphere. Most are periodic and predictable, lighting up as our orbit crosses the trail of known comets. Earth is continually bombarded by tiny meteors. They streak in at up to 150,000 miles per hour and vaporize high overhead. Sometimes they're bigger. Lumps of planetary debris the size of a fist or larger can survive a journey all the way to the surface. They descend as fireballs. One hits Earth every 2 hours. A man videotaping his office in 1992 captured this fireball in the sky over Pittsburgh. Part of it hit a car in New York. This is a typical stony meteorite. Its dark crust formed as atmospheric friction melted its surface. The friction of air also gouged thumbprints on this iron meteorite. This one may have been cracked off our moon in some ancient impact. And this may be from Mars. Beyond the orbit of Mars are the asteroids, a vast belt of debris from a planet that never quite formed, or perhaps from a collision of young planets. Heading toward Jupiter, the space probe Galileo caught a close-up of an asteroid in 1991. This strangely shaped lump named Gaspra was 10 miles long. It was our closest encounter ever with an asteroid. Pocked and battered, Gaspra was rich in metal, unlike the lighter Martian moons Phobos and Deimos, themselves thought to be captured asteroids. A 1992 picture of something orbiting beyond Pluto. A 10th planet? No. Just a 200-mile-wide ice block. This is Chiron, another asteroid-like body, but with a comet-like coma, here in blue. A piece of evidence suggesting that comets and asteroids are somehow related. Radar images of asteroid Castalia show what may be two bodies in close embrace. And this is Tutatis, which in 1992 came within 2.5 million miles of Earth. Such encounters are nothing new. At any time, some 50 asteroids buzz the Earth and Moon. The occasional major impact is inevitable. The results can be catastrophic. Like the Manicouagan crater in Quebec, a gigantic impact from 200 million years ago. And Goss's Bluff in Australia, now well eroded. Australia's Wolf's Creek crater, 60,000 years old. This relatively small one in Arizona was blasted out just 25,000 years ago. It will happen again. And what's this in the heart of Europe? It's still just theory, but some think these computerized satellite images may reveal an enormous distorted impact crater lying between the Alps and the Baltic, a harbinger, perhaps, of things to come.
Look back on a power struggle that left thousands dead and a nation in turmoil as we recall General Franco and the Spanish Civil War, part of This Century, next from the Learning Channel.